Welcome to our lesson on probability and set theory. In this lesson, you're going to learn how sets and their relationships are used to calculate probabilities. So there's some vocabulary right off that we need to look at, and if you have your notes and you're following along on your notes, you can fill in some of the blanks on your notes. First, a set. A set is a collection of distinct objects. Let's choose our class. So let's say our class is a set of students. So each person in the class would all together would make a set. Each object in a set is called an element. So in this case, each person is considered an element. So each student is an element in our class set. Let's think of going to the grocery store. The set might be all the food in the grocery basket. Each food item would be considered an element. Now, as we start looking at different probabilities, you're probably used to flipping a coin, putting different colored blocks in a bag and pulling out a block. Sometimes we even use letters of the alphabet to determine a set, and we figure out, okay, what's the probability of, if I reach into the bag, that I pull out a blue block? And then what's the probability of pulling out a blue block and then a red block? So we're going to look at some more notation, in this case what we call set theory. All right, let's look at some terminology and notation and some diagrams to help us understand what each of these is. So the first term that you need to be familiar with is called the union of sets A and B. And the way we write that is, if our two sets are A and B, we have this, it looks like a U, okay? That means that we're going to include everything that is in A, and we're going to include everything that is in B, and that's going to consider our set. So here's a diagram of it. If you remember those Venn diagrams. So if we're going to include every element in A, we're going to include every element in B, and that is called a union, and we write it with this symbol. So please add that to your notes. The next term is called an intersection of sets A and B. And the notation here is we have this A, and this time the U is upside down, B. For our Venn diagram, this would be elements that are part of A, but they're also part of B. So that's right here where they overlap. So the elements, to be part of the intersection, they have to be in A, but they also have to be part of B as well. And let's look at one more, and this is what we call the complement. And the complement of, we're going to choose set A, is all the elements not in A. So the one way to write it is with A with the C or with a tilde A, meaning the complement. So this is going to include all the elements that are not in A. So that's why it's shaded on the outside here. You're going to see this different notation as we go through the problems, and that's really what you need to memorize, is what do the symbols represent. Are we looking for the intersection? Are we looking for the union? Or are we looking for the complement? Okay, so now let's look at calculating theoretical probabilities. Probability measures how likely an event is to occur. An event that is impossible has a probability of 0, while an event that is certain, that means it's definitely going to happen, has a probability of 1. All other events have a probability that's between 0 and 1. We usually write this as a fraction. Again, this is theoretical probability, because if we actually do an experiment, so that would be an experimental probability, sometimes it doesn't always turn out to be theoretical when it's experimental, and we'll talk more about that in class. So let's take a look at some simple probability. If we have a bag of marbles, and in the bag are some red marbles, there's some blue marbles, let's say there's even some yellow and green marbles in the bag. And we want to find the probability that when we reach in the bag and pull out one marble, that it's going to be red. The way we do that is it's actually a fraction. The number that goes in the numerator is how many red marbles are in the bag. Let's say I put 5 in there. Let's say I put 5. Over the number in the denominator, is the total number of marbles in the bag. So let's say there are 20 marbles in the bag. And so that would simplify to 1 over 4. If you want to change that to a percent, that would be 25%. What if we have a probability of, what's the probability of pulling out a red marble or a blue marble? So there we have that or statement. When it's an or statement, if you recall from maybe, I'm trying to think, but maybe 8th grade, was that the last time you guys learned or talked about probability? It would be the probability of a red marble plus the probability of a blue marble. All right, so let's say we found out the probability of red is 5 out of 20 plus the probability of a blue one. Let's say I only put 2 blue marbles in. So I would have 2 blue marbles over the total marbles, which are 20. If I add those together, I get 7 over 20. And that is my probability for being able to pick a red or a blue marble. All right, let's do an example of how to calculate these different probabilities. We have a grocery basket, and in our grocery basket, there is 1 bag of each of these: an orange, a green apple, green grapes, green broccoli, white cauliflower, orange carrots, and green spinach. We're going to define that event A is picking a bag containing a vegetable. Event B is picking a bag containing a green food. So we want to start off by finding the probability of A. And I don't think I mentioned this before, but that's how we write the probability of A. We have the P, and then in parentheses, it gives the actual event. So the probability of A is going to be picking a bag containing a vegetable. Well, how many vegetables do we have in the bag? We have, we have green broccoli, cauliflower, carrots, and spinach. That is 4. There are 4 vegetables that we might be able to choose. And the total number of bags we have are 2, 4, 6, 7. There are 7 total. So probability of choosing a bag that contains a vegetable is going to be 4 out of 7. Let's look at the probability of B, which is picking a bag containing a green food. So I'm going to switch to green here since we're talking about green. Well, let's look up here. I added the pictures to make this a little bit easier. And we're not going to count the carrots because they're just orange carrots. We actually have 4 items, 1, 2, 3, 4. That would be the green apple, the green grapes, the green broccoli, and the green spinach. So that would be a probability of 4 out of 7. So it turns out the probability of A and the probability of B are the same. All right, let's go down here to the next one, which is the probability of A or B. Now what we have to be careful here, if we calculate this like I did before, the probability of A plus the probability of B, we're actually not going to get the right probability because some of these elements overlap. They're a vegetable and they're a green fruit. So let's calculate this simply by thinking about the question. Picking a bag containing a vegetable or a green food. So if we look at the things here, orange is not a vegetable, it's not green. This one's green, so that's going to be 1. Here's a green, that's 2. Here's green, that's 3. Cauliflower, it's not green, but it is a vegetable, so we're going to count it. So that's our 4th. Carrots are a vegetable, that's 5. And spinach is a vegetable. And so that gives us 6 items. So in this case, the probability of A or B would be 6 over 7. Now, another way for you to think about it that we're going to talk in the future is that it's going to be the probability of A plus the probability of B minus any overlapping, the probability of A, B. But we'll talk about that in the future. For right now, you can just look at the items and count them up. All right, and our last one, the probability of A and B. So that word and, meaning it has to be a vegetable and it has to be green. So let's see how many vegetables we have that are green. We have broccoli and we have spinach. Those are the only two that are vegetable and they're green. So we're going to have 2 out of the total 7. All right, one more example. This is actually in your book on page 953. You take the numbers 1 through 30. They're written on slips of paper and they're placed in a hat. Students draw a slip to determine the order in which they give an oral report. You've probably done this in class before. Event A is being one of the first 10 students to give the report. Event B is picking a multiple of 6. If you pick first, calculate each of the indicated probabilities. Now that last statement is important because if you weren't the first person to pick, then our sets actually change. So the first step in finding the probability is we want to write out the sets. And I've done that for you. Set A is being one of the first 10 students. So that means that set includes the numbers 1 through 10. Event B is picking a multiple of 6. So here's the numbers from 1 to 30 that are multiples of 6. So 6, 12, 18, 24, and 30. Once you write those down, it makes it much easier to calculate the probabilities because you can just simply look at the numbers. So if we're calculating the probability of A, well, we know there are 10 numbers in set A, 1 through 10, but there are 30 slips of paper. So 10 out of 30 or 1/3. All right, do you remember what this symbol means right here? Okay, that is an OR. That means the probability of A or B. Now be careful on this that you don't include any that overlap. So we know we've got 10 from event A, 1 through 10. Now let's look at B. Well, we can't include 6 because we've already included it over here. So we don't want to count it again. Okay, so we're going to skip 6 and say we're going to add 12, 18, 24, and 30. That gives me 4 more numbers. Again, I have a total 30. So this probability is 14 over 30, which simplifies to 7 over 15. All right, here's our next symbol. This means intersection. So this means the probability of A and B. So we're looking at numbers that are included in the set A and they're also in B. So if we look at those numbers, let's see, 6 is in both of them. But I think that's the only number they have in common. So there's only one number they have in common. So that would be 1 over 30 for our probability. And the last one, this is the complement of A. So that means the probability of not A. So what's the probability of choosing a number that is not in set A? And I'm going to let you give me your answer for that one. All right, there are 20 numbers from 1 to 30 that are not in A. So that would be 20 over 30. Another way you could figure that out would be 1 minus the probability of A, which is 10 over 30. Of course, that simplifies to 2/3.